Building secure and reliable smart contract can be tricky and time consuming. But what if I can tell you that they are ready to use smart contract that you can implement and or import in your application and speed up your process? That's why we are going to talk today about Open Zeppelin, which has some ready to use contract like ERC721 token, Enumerable to and some other contract like that one that you can use today in your project and speed up the process. So let's quickly look at those projects or those contracts and see how we can use them. All you're going to do is to head over to GitHub and search for Open Zeppelin. You just come to the search, you click on Open Zeppelin, and you'll see Open Zeppelin / Open Zeppelin contract. And that's the folder that you are going to work in. So right here, you'll come back to this, or if you searched for Open Zeppelin as an organization, you'll see this page. So all you need to do is to click on Open Zeppelin contract, and you'll come here to this folder called contract, because we are going to see what are the smart contract or the ready to use smart contract in that folder, and everything here is related to contract. Okay, that's how it has been structured. So we are going to walk over all these folders and see the smart contract that are inside and see what are their uses. Okay, so we start with access. So as you can see, we have 1 2 3 4 5 6. We have 6 smart contracts that we can call in our project. So what are their use cases, or when can we call them? So here, most of these contracts are called when you want to grant a certain role to a certain address in your smart contract. Okay, so if we start with access control, so you'll see here that this contract here allows to grant and revoke roles, right? So I'll just show you some contract here. We have this has role to check if a certain address or a certain account has a certain role. Okay, or let's say you want to see if this account is an admin in that smart contract, so you can call this has role. You place in the role and the account. Okay, so we have check role. We also have another one down here that get role admin to know which address is the admin and such stuffs. So we also have other contract where you can the admin can revoke a certain role. So basically, all the functions that are in this smart contract are related to roles. Okay, let's say let's give an example. You're having a smart contract that is ERC20. Okay, so you'll be like, if a certain person or a certain address has a certain role in my smart contract, maybe they can be able to burn some tokens. Okay, that's the idea behind this. So if we get out of this smart contract, we go to the second one. Okay, we have access control enumerable. So what this does, or we have a couple of functions here. Okay, so we can have the role of a certain account just as the other contract. Okay, but they're split. We can grant a role. Okay, we decide which role we grant to which address. We can revoke a role. So if we go down, we have this other smart contract, almost the same thing. Okay, we can see if the admin role has changed. We can we have here grant role. Yeah, I believe we have grant role here. Yeah, grant role, we can get the role to the admin and such stuffs. So basically, those are the biggest contract that are inside of the access folder. So as the example I gave before, you can have your ERC20 and you want to grant access to certain roles according to the role that each account has. Okay, the way I told you, if your smart contract has a role to burn some tokens and you want to grant that role to a certain account, you can use one of those. And we have the ownable.sol, and basically this one is used in most of the it's used in many smart contract. Okay, so we have here, you can transfer ownership. Okay, and this says initialize the contract setting to deploy as the initial owner. So if you say maybe a contract is ownable, that means the owner of the contract will be the person who will deploy the contract. And maybe if you want to change the role later, you can change the role. Okay, so it's right here. You can renounce ownership and you can transfer ownership. Okay, let's say I'm a developer, I'm building a certain marketplace, but at the end of the day, I would like, after deploying the contract, I send the ownership of that marketplace to the person who gave me the work. Okay, so let's say a company told me to deploy the smart contract and give back them the work. I can do that ownable, so that I deploy the contract the first time. As you can see, if a contract is ownable, the first time the contract will be assigned to me. Then I can change that, okay? And I put the address of another person or of another contract. That's basically what the ownable.sol does. As you can see, you see on deployment, you have the ownership goes to the message sender. That means the person who deploys, okay? And if you want to know the owner, you just call this function. You have also a modifier here, but you have renounce ownership, transfer ownership, and transfer ownership right here. These are two smart contracts. I mean, two functions that are different, and they do different roles. Okay, so that you see this transfer ownership is this one defined here, and we are using that in this other function, and we have a require here. So that means this ownable transfers the ownership of the smart contract. So you can use that depending to your needs, or depending to what you want, or you would like to transfer maybe the ownership later on. So basically that's it for the access. Okay, that's it for the access folder. Second, we are going to go to the finance folder. Okay, though it's not mostly used, but we are going to go through it. Inside of finance, let's just dive into the finance folder. You'll see we don't have so many things. So we have payment splitter.sol. This is a contract that helps you split let's say your revenue. So let's say maybe you have an application, okay, or a smart contract that receives money, okay, from multiple users, and you want to split that money between the founders, okay? So instead of doing that yourself, you can implement some of these functions to do that automatically. So you split some amount of money between some founders, okay, or between some beneficiaries according to a certain percentage and such stuffs. So if you use the payment splitter, as you can see here, let's look at the function. You have total shares, okay? You have the total release. That means the amount that has already been released. So you have down here, you have shares, again, you have released for a certain account, okay? Um, as you can see, they say getter for amount of ether already released for a payee. So you have basically another release function, and what all these functions do, okay, we have pending payment, by the way, and we have add payee. So all these functions do is the following, okay, like add payee right here. You add another account. Let's say you have another investor, okay, and you want to add them among the people who receive some amount of money according to how the organization is gaining profits. So you add another pay, you add his account and his shares, okay? So that means the total of his shares that will make him benefit some amount of money according to some total shares, right? I think it's that easy. So that's what this contract is about, and all the functions that are inside. So we have vesting wallet.sol. As you can read right here, it says this contract handles the vesting of ETH and ERC20 tokens for a given beneficiary. Custody of multiple tokens can be given to this contract, which will release the token to the beneficiary following a given vesting schedule. Okay, this vesting schedule is customizable through the vested amount function. So if you come here and see the vested amount function, let's look for it. So these are the duration, released, start. Okay, and if we go down, vested amount, okay, and this takes in a timestamp, as you can see. calculate the amount of ether that has already vested. Default implementation is a linear vesting curve. And this function, it takes in a timestamp sorry, a timestamp, and it returns vesting schedule at address to this. That means the address of the contract, and you get the balance there plus the released. And these are, vesting schedule is another function, and released is also another function. So basically what this does, as they told us up here, it vests a certain amount of ether, okay, to a given beneficiary. So basically that's it about the finance. And now we have to go to governance. So in governance, we have some other folder, okay? We have compatibility, extensions, and utilities. But we can start with governor.sol. So just a couple of seconds. So in governor.sol, what we are going to do here is to, as you can see, just a quick second. So this whole contract is mostly used when it comes to DAOs, and DAO stands for Decentralized Autonomous Organization. That means the governance here, it's basically, let's say you want to vote, okay? You want to vote for a certain rule or a certain proposal. So we have functions here to get a proposal to but these ones up, as you can see, this contract is pretty long, so it inherits from other contracts that we'll see later. Like you can see, most of them are utilities, okay, but we'll go through them later. That's why I'm skipping this upper part, okay. And you can see we have a modifier, only governance. That means only the governor can call that function, okay. And if we go down, you'll see name, okay. This is the name of the governor, okay, governor name. And we have the version, that's not, but we have the proposal down here. And we have what I wanted to show is just let me see. These are the proposal states, okay. So for a proposal, you have to start a proposal, to vote for a proposal, and the proposal can be either executed or cancelled. So all those if blocks that you are seeing right there. So we have a proposal snapshot, okay. We have a proposal deadline, a function for a proposal deadline. We have a function for if the vote, the proposal has been voted successfully or has been cancelled. That's all we have here, and all the functions that relate to the governance, basically. So when I go down, you see a function before execution is triggered. That means when the proposal has been voted successfully. Now before execution, we have after execution, we have cancel, when a proposal has been cancelled, or a function to cancel a proposal. We have a cast vote with reason. You can cast a vote. And basically, I think everything is explained clearly, right? So if you're importing maybe this contract into and you're trying to create a DAO, you have all the functions that you need for governance, okay? And I think that's why it's called governor.sol. So the person governing will call some functions right here, right there, okay? And this one is basically almost the same thing, okay? We have an event where when a proposal has been created, you have an event, okay? And here we have a couple of events. The proposal has been executed, proposal cancelled, okay? Those are some of the events. So we have a hash proposal. We have a function of the state. We have the function of proposal snapshot. That means the snapshot of the proposal. We have the deadline, okay, voting delay, voting period. That's the period where you can vote for a certain proposal. So you can vote either for or against. You can get all the votes, okay, and you can see if a certain address has voted or not. And you have a function to propose, right? When you have a new proposal, you can propose. Execution function to execute a certain proposal and such stuffs. So if you come back and you come to compatibility, So it have governor compatibility.sol, and right here we have some other function related to the, if the governor, I mean, if an address is compatible with the governance rules and such stuffs. Apart from that, we have some extensions. Okay, I won't go through these extensions because those are some, if I'm to call them, behind the scenes what happens. So they have been split to let the overall project keep the to let the project keep a certain aspect, okay, or a certain architecture. So we have some utility functions. These are some of the event and other functions of getting votes, get past votes, and so on. Those are the utilities. So that means if you want some to create some sort of a decentralized autonomous organization, you can use some of the Open Zeppelin governance contract to, according to what you want, according to what you are intended to do, and you can use some of the ready to use contract and save a bunch of time when you're doing that. So after governance, next step, we are going to go just an overview on some interfaces, right? For interfaces, these are going to be pretty small contract, okay? Because they'll be like implementing or importing some other contract. So we are going to, there are so many files here. I won't go through them all. We have like ERC777 token. We have 721 tokens. These are the ones you know. Most of you know, sorry. ERC20 model. I mean, ERC20 so that's all. It's also for ERC20 tokens, cryptocurrency, and such stuffs. We have 1155 tokens. These are for NFTs. So if I open like this one, you'll see it's a pretty simple contract. Okay, you import Solidity, you import a token now, but we'll see tokens later on. But as you can see, import the ERC 1155. I mean 1155 token, and you have like this is the ERC 721. As you can see, same thing, it imports another token. So they are just interfaces, and I won't go through them for long. So when we continue, I will skip MetaTX, MOX, and Proxy. Okay, I'll skip those ones because they contain some other code that are like utilities for most of the codes that we use. So I'm going to go through the ones you encounter most of the times. Okay, so I'll go maybe next I'll go into this this folder here called security, because we have some pretty solid contracts here, like possible. So this contract happens maybe if you have a bug or if you have an attack into your smart contract and you want to pause everything, okay? Because sometimes when you have an attack, you don't want your smart contract to continue working, okay? Before you fix the bug. So here, as you can see, we have paused by default is false. That means by default the contract is not paused. So it's how, if I'm to say it's on play mode. But now we have this contract called, this function called paused, and this function basically returns true or false to know if the contract is paused or not. So you can see here we have a modifier and we have another modifier. So when not paused and when paused, those are just modifiers. So if you see here, you see function pause. When you want to pause a contract, you have to first check this modifier if the contract is not paused. Okay, so there you are going to set pause to true. That means you are pausing the contract. So you can also unpause the contract. That means you are setting pause to false. So you'll see before you have a modifier to check when paused, then you set that. Okay, so if you check this modifier that said when paused, the modifier is up here and it requires paused. Okay, and this paused, remember, this paused will return a boolean, so true or false, and if not, the error will say pausable not paused. Okay, so that basically it requires you not to set not to set paused to false when the contract is not paused, right? So it's like maybe a movie is on pause, then you re-click pause. I mean, it doesn't make sense, right? That's basically what those modifiers are doing there. It's not to redo the same task that is already running. So we'll have the pull payment that's all. Okay, so we go through it as they say here. Yeah. Pull payments are often considered the best practice when it comes to sending ether security wise. It prevents recipient from blocking execution and eliminate reentrancy concerns. So we'll talk about reentrancy in the next, in the next contract. Okay. So as you can see, this contract is a pretty small contract. So we have a function to withdraw payment and a function for payment. Okay. So the function for withdraw payment, it says payee whose payment will be withdrawn. Okay. And I think the all the all the comments that are here explain everything. Okay. And here we have payment returns the payment owed by to an address. Okay, so as you can see, we have to pass an address and see all the payment that we owe that address. So we have also asynchronous transfer and so on. So next we are going to look at this reentrancy guard tool, and this is implemented in so many contracts. So basically this reentrancy guard has been created after the 2016 DAO hack that was responsible for the loss of many millions. I don't have the number exact in my mind, but basically what it was doing is a contract was recalling, or the hacker was recalling the same function before the execution is done. So he was able to withdraw money continuously without finishing the function execution. That's why this reentrancy guard has been introduced to prevent a function from being called again before the execution is done. So that basically what happens with this function. um I think we are done with this. We are done with security. Okay, so we are going to go to token. But before we go to token, I think let's first talk about utils. Like, we have some utility functions here that we are not going to go very much through because they are already implemented in other part of, in other contract. Okay, we have cryptography. So here we have market proof, signature check to check if the signature is true or not. Like when you are trying to sign a message with your wallet or with your private key, you have to check that the key that has sent the message is really the right key. Okay, we have Escrow here. Those are some, if I'm to call them, low level contracts that, they're just utilities. So to understand them, you have to go through so many other things. And we have counters. So basically counters helps, it helps to increment. Okay, it helps to increment a number safely. Okay, so instead of incrementing the number yourself unsafely, so counters.sol will increment that safely, so that you don't have any branch for a hacker in your contract. Okay, or if so that you don't access other values out of their scope. So here we have also arrays. Okay, as you can see, collections of functions related to array types. So you can find the upper bound of the array. You can have the low, I think just the upper bound right here. So you can have, you can find the upper bound of the upper bound of the array, and this will return an integer. Okay, as you can see right there, we have context.sol, checkpoints. I won't disturb you very much with those ones, but where we're going to spend most of our time is it's in token. Okay, so here, as you can see, we have 4 types of tokens. We have ERC1155, ERC20, ERC721, ERC777. So to start, we are going to start with the simplest with the simplest contract, that is erc20.solve. Okay, and I'm not going to go through the extension or what, but I'll go through the actual contract. The erc20.solve contract. So basically, this contract is the one we use to implement or to create a cryptocurrency. We have some functions here that you can see, like function name. It's the function that helps you to set the, or to recover the name of the contract, not to set it. To set the name of the contract, of the token, sorry, you set it on construction. So you set the name and the token and the symbol. Okay, so maybe let's say for Ethereum, when that was deployed, okay, they set the name to Ethereum, they set the symbol to ETH. Okay, it's done right there. And to recover the name, you just call function name, and you recover the name of the token. Symbol, you recover the symbol of the token. Okay, decimals, those are the number of decimal places. Okay, total supply is the total supply of tokens minted. If there are 1 million tokens, you recover all the total supply, that is 1 million tokens. And balance of recovers the balance of a certain address. Let's say I have my address, so if you call balance of my address, you'll know how many tokens I hold. So we have transfer, the function. This function helps to transfer a certain amount, okay, to a certain address. So if you want to send me some money, or basically when you go to your wallet and you send some money, okay, they call the transfer function to transfer me money. So you have allowance, you have approve, to approve a certain transfer. Okay, we have transfer from. So you see, it takes in some parameters. Okay, the address from, the address to, and the amount. So you transfer from X address to Y address, and you transfer a certain amount of tokens, basically. So if you go down, you have increase allowance, we have decrease allowance. Those are some other functions that you can use. Again, you have the transfer function right here. Yeah, and that's basically it. Those are most of the functions used. And as I said before, you can burn some tokens. Okay, I think that the thing that is happening with most of the tokens, when they want to increase the price, they burn some tokens they burn them from the total supply. Okay, and that's basically the most of the function is in the ERC20 token. So maybe when you want to create your ERC20 token, you don't need to write all those ones or all those functions. All you can just do is to, it's to import that contract in your project and just use the functions, right? Because your own contract will inherit from ERC20, and it will be easy to use all those functions that are provided right there. But it's quite good to know how those functions work, because you'll implement them in your own contract. So you have to know how they work or how you're going to use them. Okay, so the rest is not that much important. Okay, or you don't need to know the rest. So we have, after ERC20, we have ERC721 token. This is the basic standard for NFTs. And if you come to this contract here, you'll see that this contract is quite large or quite long. Okay, so again, we have some utilities, the ones that I did not want to go through. Okay, so we have some mappings, constructor. And if you're watching this video and you already know all the basics of Solidity, you understand what's happening right there. So next we are going to have balance of owner. Okay, to know the balance of a certain owner, and the owner is the address. Here, owner of, it's basically when you have an NFT and you want to know who is the owner of that NFT. Okay, you can call this function and you put the token ID. Okay, so the ID of that NFT, so you get who is the owner. And as you can see, it returns an address. So we have the name. Okay, you can call name and get the name of that NFT. Symbol, same. Token URI, and token URI most of the time is is a link to where the NFT is stored on a decentralized network or on a decentralized file storage most of the time, like IPFS, NFT.storage, Filecoin, and such stuffs. So moving forward, okay, we have approve. So you approve a certain address to move your token or your NFT. We have get approved. So there you are getting approved to move a certain token. Set approval for all. You are approving all the tokens that you own that they can be moved by a certain address. Okay. So here you see the operator is the address that will move all your tokens. So you grant him access and is approved for all. This will return a boolean to know if a certain address is approved to send all the tokens or all the NFTs of a certain contract or of a certain address. So we have the transfer method, transfer from. So if I have an NFT, I want to send it to you. So it will be transferred from me to you, and we have the token ID to know which ID we are transferring or which NFT we are transferring. And we have the safe transfer. So this transfers a token safely, so that you don't transfer your token from you don't transfer your token to a non ERC7 or non ERC721 receiver. That means to make sure you're not transferring your token to the wrong address where it will be locked. So moving down, we have some other contracts, not contract but functions. Okay, is approved or owner, those are for approval. We have safe mint when you are minting your token. Okay, so if you go to a launching websites where they say mint your token, so they call this safe mint function to mint a certain token and get it to your address, right? That's safe mint. So moving down, we have mint and safe mint. Basically, it's better to use safe mint than mint. So we have burn. You can burn a token as an ERC20. You can also burn an ERC721 token. We have transfer, the transfer of value. Okay, so but it's better to use safe transfer instead of transfer. And I'm not seeing where it is. Yeah, so safe transfer from, sorry. So that you know at least you are transferring your token safely. So if the receiver is not a ERC721 receiver, or that receiver is not able to receive your token will not be sent, and in that same case it will not be locked. Okay, so basically those are the biggest function right there. So if we move forward, we have ERC1155. So the way I told you, ERC1155 is basically also used for NFTs. So you can get basically some additional functions here, but the rest or the whole process is almost the same. So if you want to know more about this, you can see set approval is approved for all. Okay, but now you have safe batch transfer from. Okay, those are now the differences. And if you want to know more, you can also check this. You can check this readme by yourself, or dig more about that, or dig more into that. So we have ERC777. Oh, sorry, wrong one. So if you come here to ERC777, you also get basically the same thing, but this one is used also for, it's used for fungible tokens. So if you see here, this implementation is agnostic to the way tokens are created. This means that a supply mechanism has to be added in a derived contract using mint. Okay, so support for ERC20 is included in this contract. As I said, it's also for fungible tokens, so ERC20 support has to be included as specified by EIP. Both the ERC77 and ERC20 interfaces can be safely used when interacting with it. Both ERC77 send and ERC20 transfer events are emitted on token movement. Okay, so basically this one is kind of an improvement of an ERC20 token. and you can also dig more into this because I'm just giving a basic overview right here. So down here we have some, we have some common token, if I'm to call them like that. So as you can see, they say functionality that is common to multiple token standard, ERC 2981. NFT royalty is compatible with both ERC 721 and ERC 1155. For ERC 721, consider ERC 721 royalties, which clear the royalty information from storage or burn. So basically, here we have just some this, we have the contract of the ERC 2981, but I don't know much about that, so I won't go deep into it, but I'll leave the link to this repo in the description below, so that you can also check it and enlarge your search or your documentation about this. As I said, this was just a walkthrough, so that if you want to do something, at least you know where to find that contract, because most people want to do something but they don't know where to find the right resources to do that. That's why I wanted to help you in this walkthrough of Open Zeppelin contract, because I know there are so many ready to use contract there that can make your development process easier.